NCM Learning Center. Morning friends, now I am going to explain about lenses optics. It is one of the very important general science topics for TNEB and other government engineering examinations. Let me discuss. Mainly the optical lenses are classified into two. One is convex lens and another one is concave lens. The symbol of convex lens is like this. For the concave lenses, mainly the lenses have three rules. The rule 1 for the convex lens is if the rays passes through the optic center, this is optic center, if the rays passes through the optic center, it goes straight without any deflection. This is a convex lens. If the ray passes on the optic center, it goes without any deflection. The same rule is applicable for the concave lens also. The center axis is called as principal axis. By the rule 1 for the concave lens, same. If the rays passes through the optic center, it goes straight without any deflection. Center axis is called as principal axis. Rule 2 for the convex lens is if the rays passes parallel to the principal axis, after refraction it goes through the principal focus. Principal axis, if a ray passes on the parallel to the principal axis, after diffraction it goes through the principal. This point is principal focus. The rays parallel to the principal axis, after refraction it goes through the principal focus. The convex lens converges the optical beams to the focus. Rule 2 for the concave lens is the concave lens diverge if the rays passes parallel to the principal axis, after refraction diverge from the principal focus. Parallel to the principal axis and diverge from the center of from the principal focus. This point is principal focus. They diverge from the principal focus. Converge to focus. This is diverge from focus. Length from optical center to principal focus is called as focal length. Rule 3 for convex lens is if the ray passes on the principal focus, after refraction it goes parallel to the principal axis. This is the principal focus point. If the rays passes on the principal focus, after refraction it goes parallel to the principal axis. For the concave lens is same. A ray which passes towards the principal focus, after refraction it goes parallel to the principal axis. Concave lens, this is the principal focus. The ray passes towards the principal focus, but here in the convex lens passes on the principal focus, but the concave lens the ray passes towards the principal focus. This point is principal focus. Towards the principal focus, after refraction goes parallel. This is the rule 3 for the concave lens. The image formation by the convex lens. Let me do a simple experiment. Let us take a scale and pencil. First case, if the object is beyond 2f, okay, what the image appearance? Just draw a convex lens and draw a axis. Optical center, principal focus, 2 times of focal length. Take 2 cm. Focal length is 2 cm. Just a scale. Mark the 2 centimeters, 4 cm on the axis. Okay. Let us take the image presence on the 5 cm from the optic center. The object length is 2 cm. Let us take. We know that rule 2 and 1. By the rule 2, if the rays passes parallel to the principal axis, after refraction it goes towards the principal focus. Okay, this is rule 2. Just apply the rule 2 and apply the rule 1. Rule 1 means if the light beams passes on the center of the optic center, it goes straight without any deflection. Apply the rule 1 also. The two rays, rule 1 and rule 2 rays meet at this point. This is the image appearance. A dash and B dash. The image appear between F and 2F. Okay. Just measure the length of the image. The image length will be 1 cm. By the conclusion, if the object is beyond 2F, the image appearance will be between F and 2F, and the image size will be T-minus image. T-minus image means if the image size is less than object image, the image is T-minus image. Now real image, inverted image. What is real and virtual image? If the object and the image appearance on the same side, that image will be a virtual image. Object and appearance image other side of the lens, that image will be a real image. Here object is on the left side and image is present on the right side, so that image is the real image. Okay. When you drive a car, just observe the mirror. Okay, you can see the two types of image. One image is the other side of the objects. You can see the other side of the object, that image is real image, and the same thing you may see the image inside the car, that image is virtual image. Case 2, if the object is at 2f, draw a convex lens and the axis, principal axis, let us take the focal length is 2 cm. The object present at 2f, the length of the object is 2 cm. Okay, just apply the rule 1 and rule 2. The two rays meet at this point on 2f. The length of the image is same depth of object, 2 cm. By the conclusion, image appear on 2f, same size of image, real image, because the object is left side and image is right side, like right side of the lens. So real image and inverted image. If the object is between f and 2f, what will be the image appearance? Okay, let's just draw a convex lens and the principal axis. Let's take the image is present at the 3 cm from the optic center, because the focal length is 2 cm, the 4 cm, object length is 2 cm. Apply the rule 1 and rule 2. The two rays meet at this point above the 2f. The length of the image is much higher than the object, magnified image. By the conclusion, appear at above 2f. If the object is between f and 2f, the image is magnified image and the real image and inverted image. Fourth case, if the object is at f, just draw the convex lens and the principal axis. The object is present at f, the length of the object is 2 cm. Apply the rule 1 and rule 2. The rays does not meet. So the image appears at infinite distance. The length of the image is infinite. Image size is infinite, and real image inverted image. Case 5. If the object is between focal length and optic center, what will be the image appearance? Just draw. This is a convex lens, principal axis. Let us take the object is present at 1 cm away from the optic center. The focal length is 2 cm. Apply the rule 1 and rule 2. Does not meet on the right side, but the virtual rays meet at the above 2f. So the virtual image will appear at the above 2f. The image size will be much higher than the object size. That image is virtual image because the object and image on the same side of the lens. Okay, so the image will be a virtual image. So by the conclusion, appear beyond 2f and image size is magnified image, virtual image, erect image. Erect image, not inversion. Erect image means not inversion. Okay. Case 6. Last case. If the object is at infinite distance, by the rule 2, it appears on the focal length. The dimension of the image is dot size and real image. Okay, this is the image formation by the convex lens. Now we will discuss the image formation by concave lens. Let us take the concave lens. Do the same experiments. Okay, if the object is between infinity and optic center in distance, let us take the object is present between f and 2f. Apply the rule 1 and rule 2. But for the concave lens, the rays passes parallel to the principal axis, diverge from the focus length. Okay, this is the rays. This rays is virtual rays. The virtual rays meet at between f and o, between focal length and optic center. The image is virtual image because object and image on the same side of the lens. Length of the image is much lesser than the object length. Appear between FNO, virtual image, erect image, not inversion. Okay, not inversion, diminished image. That means the dimension of the image is lesser than the object image. Case 2, if the object is infinite, by the rule 2, parallel to the principal axis, diverge from the principal focus, so the image appears at the principal focus, appear F. The size of the image is dot size, dot. Virtual image, not erect. Erect, this is image formation by the concave lens. Okay. For the image formation, just do the experiment. Take scale and pencil, draw this, apply the rule 1 and 2, then only you can understand. Okay. Relation between focal length, object distance and image distance. Okay. Do a simple experiment, same experiments. If the object is 5 cm and focal length is 2 cm, the image appearance will be 3 cm away from the optic center. Okay. By the lens law, 1 by f is equal to 1 by u plus 1 by v. F means focal length, u means object distance, v means image distance. Okay. Just apply on the formulas, plus substitute f is equal to 2 cm, u is equal to 5 cm, you will get v is equal to 3 cm. So the experiment result as well as the lens law formula is same. Hence the formula is verified. If the image is virtual, if the image appears on the same side of the object, v will be considered as negative. Okay. Thank you. Thanks for watching. Click the subscribe button and hit the bell icon for notification. Like, comment and share. See you next time.